Hello everyone, I am Dr. Anil Shirahatti, a professor and consultant. So in today's session, that is session 7th on module 3, we will be studying what you mean by effective interest rate and what you mean by continuous interest rate. And we will be solving few problems to understand both effective and continuous interest rate concept. So interest rate or the nominal interest rate are normally quoted as on annual basis. However, agreement may be specified that interest may be compounded several times per year. It may be monthly compounding, quarterly compounding, semi-annually compounding, okay, etc. Now, for example, a 2% interest rate per quarter can be quoted as 8% uh, per annum interest rate compounded quarterly. So in this case, the interest rate is 2% per quarter. It can be represented by 8% interest rate, which is compounded quarter. Okay. Now, many times you saw all these pictures either in your televisions or papers, okay, digital media. So you can see here in the right picture, the person is saying 7% interest rate per annum. Okay, here if you see the interest rate is 8.25% per year and there is a star. Now the star, and sometimes they can say okay, 8.25, and let's say in this case also he is saying 8.25 per annum. Okay, but if this person says 8% 25 and put a star and say it is compounded every month, okay, definitely that effective interest rate, it will be more in this first case. Okay, now how this is there, let's understand in future slides this concept. Now how I should calculate the effective interest rate, that you have to understand first. So effective interest rate can be calculated using the formula, that is I effective equal to 1 plus R by M raised to M dash minus 1. So this is the equation to calculate the effective interest rate, where R is the nominal interest rate specified, M is the number of compounding per year, and M dash is N into M, that is total number of compoundings. Now let's understand this one with a simple problem. In this case we are simply calculating what is the effective interest rate. Okay, now determine the effective interest rate for a nominal annual rate of 8%, that is compounded first daily, monthly, quarterly, semi-annually and annually. Okay, so let's start. The If a person says, let's say in this case 8% is given, okay, and star, he puts a star and says in one case compounding is done quarterly, or in some cases compounding is done monthly or daily or semi-annually. So what will be the actual interest rate we have to find? That is nothing but the effective interest rate we want to know. So in this case, the R, whatever you are seeing, that is the annual nominal rate is given. So that is denoted by R. R only we know. So let's start first with the annually. So what is M? M is nothing but, you saw here, the number of compounding per years. So in our case we are using M is for 1 year only we want to calculate. Okay, so that is why M is equal to 1, M dash is equal to N into M, that is 1. So in all the cases we are using for 1 year only. Okay, so we'll try to substitute 1. What is R? That is 8%, 0.08. Then it is 1, M is also 1, and we are getting 0.08 or 8%. So what you mean? In this case, the 8% nominal interest rate is nothing but it is per annum only. If nothing is given, it means per annum. Okay, so annually per annum means this is also annually compounding, and per annum there is no change. So that's why you are seeing both interest rate are same, or effective interest rate and nominal interest rate are same. Let's go to semi-annually. In semi-annually, M becomes 2. So number of periods a year is every 6 months you are calculating interest on interest. For what you mean by this one is, let's say the year is divided into two parts. 1 to January to March, sorry, January to June and July to December. Okay, so first 6 months, that is 0 to 6 month. Okay, so what, let's say, what will be the principal interest charge? That will be P into I. Okay, so this is the interest charge. Now if you want to calculate the value for F, in this case F will become P plus P into I. Okay, so this is the interest rate whatever you have earned. Okay, and that is the principal amount. Now let's say for simplicity I am denoting it by F1. Now from 6 to 12, what happens? Your this will become your principal. So at the end of 12th, F2 will be equal to F1 plus F1 into whatever the interest rate. Okay, in this case of a compounding is done every 6 months. So in this case, how many periods are there in a year? Two semi-annually, 2 6 months are there. So that's why 2 for 1 year we are calculating. That's why it's 1 into 2. In generally, M and M dash are always we will be using same. It's a thumb rule. So 0.08, that is the 8%, 2 raised to 2, we are getting around 0.0816 or 8.16%. So you can see the effective interest rate is increased. Let's go for quarterly. So how many quarters are there in a year? That is, a year is divided into 3 months. Okay, so each 3 months is equal to 1 quarter. So 12 months, and how many quarters are there? 4 quarters. Okay, so of 3 months each. So that's why M is 4, M dash is 4, and R is again 8%. We substitute 4%, 4 and 4, and we are getting around 8.24%. So you can see the quarterly, again the effective interest rate is changed. Monthly, how many months are there in a year? That is 12 months, and we are again calculating for 12 periods. So 12 and 12 both sides. Okay, 8 is the interest, and we got around 8.299. What about daily? Now in this case we are doing an assumptions that there is a leap year. It is not a leap year, that's why it is 365 days. So M is 365, M dash is 365, and we got an interest rate as 8.328. So if I summarize this one, for 8% compounded annually, the interest rate is coming as 8% only. 8% is percentage compounded semi-annually, effective interest rate I am getting is 8.16. 8% compounded quarterly, the effective interest rate is getting around 8.24. 8% compounded monthly, the interest rate I am getting around 8.30. 8% compounded daily, I am getting an interest of 8.33. So you can see, as the compounding period is increasing, the rate of interest is go on changing, and the rate of interest is increasing. Okay, so as the compounding increasing, compounding period is increasing, the whatever the interest you have earned will go on increasing. Okay, or in case if you are borrowing the money, the interest will increase. So what it means is, suppose there is an advertisement and it says the interest rate is 8%, and it says compounded annually, the actual interest rate they are charging 8% only. Okay, but if they say compounding monthly, so definitely they are charging actually 8.3, but they are doing an advertisement saying 8% star compounded monthly, so you can see 8.3. So this is a advertisement gimmick, but you have to ask whenever you are dealing, either you are keeping a deposit or taking a loan, what is the compounding you are doing, whether you are doing monthly, quarterly, semi-annually, or annually. Okay, so that as a user or a customer you have to ask the respective financial institutes. Now let's solve one more problem. In this problem, a person takes a loan of rupees 10,000, okay, and from a bank at an interest rate of 10% per annum. If nothing is written, by default it is per annum. Okay, find the total amount he needs to pay back at the end of the year if interest is compounded semi-annually, quarterly, or monthly. So he is taking in loan of 10,000 at an interest rate of 10% per annum. But if the interest is charged semi-annually, what is the amount he is paying? If it is quarterly, how much amount he is paying? And if it is monthly, what is the amount he is paying? So what is the given data? The principal amount is given, which is denoted by P equal to 10,000. Then the nominal interest rate is given 10%, that is should be 0.1. Okay, so it should be 0.10, and the time period is 1 year. After 1 year we are paying it, and we want to know at the end of the 1 year what is the amount the person will pay. Now, so let's solve this one. In case of a semi-annually, what is the value for M and M dash? It is 2 each. Okay, because 6 months in a year. So first we will calculate the effective interest rate. Effective interest rate is 1 plus R by M dash. So we are substituting 0.12 by raised to 2, and we are getting effective interest rate as 10.25%. Okay. Now we know in the last class the formula for future sum is P into 1 plus I. Okay, so instead of I we are substituting the effective interest rate, that is 10.25, and we are paying back the money at the end of first year, so that's why n is becoming 1. When you substitute this one, we got an amount that is 11,025. So at the end of first year the person has to pay 11,025 rupees if the interest is compounded semi-annually. Now if the interest is compounded quarterly, how many quarters are there per year? 4. Okay, and we are again substituting that 4, again 10%, we got around 10.38%. Okay, so here interest rate is 10.38%, and if we substitute the future sum, again f is equal to p into 1 plus I effective raised to n. I got this equation, and the amount got is 11,038 rupees. Similarly, I can go for the third case where m is becomes 12, because every year will have 12 months. M dash is also 12, and once I substitute and calculate the I effective, I am getting around 10.47%. Okay, so this is 10.47%, and then using the equation f is equal to 1 p into 1 plus I effective raised to n. I can substitute where p is 10,000, I is 10.147, and n is 1. So I got around 11,047 rupees. So you can see in this equation, the first I got 11,047, in the last case 11,038 and 11,025. Okay, so this is 11,038, one more, and 11,025. Okay, so as the compounding increases, the amount a person has to pay also increases, because the interest earned is more. Okay, or interest he has to pay back is more. Now if there may be a situation where a person says, I want to do the compounding continuously, or every second I want to do the compounding. Then what will be the effective interest rate? Let's calculate that one. Now the ultimate limit for the number of compounding per period in 1 year is called continuous compounding. So in this case, every second I am compounding. Okay, next second the principal plus interest will become the new principal. So next again second, principal plus interest earned becomes a new principal. Under this pattern, m will approach infinity. Okay, as the interest compound continuously moment by moment. So we are using the regular uh, interest, that is I effective interest rate formula, that is 1 plus r by m raised to m minus 1, because here we are calculating for 1 year. Now what happens? M will tend to infinity because the period I'm making as small as possible. Okay, so I will put the limit m tends to infinity, 1 plus r by m raised to m minus 1. Now I'm just trying to rearrange. Okay, so m by r into r, again it becomes m only, so I just rearrange. So we know this one with the limit is nothing but the value for E. So I effective is nothing but e raised to r minus 1. This is applicable only when it is a continuous compounding problem. Okay, and I want to find the interest. Now you can solve this equation where I am saying, let's say principal is 200 rupees, nominal interest rate is 8%, time period is 1 year. Find the future sum using continuous compounding interest rate method. So let's say, what is the P given as 200, R is 0.08, 8%, N is 1, F we want to find. So first is we have to find the effective interest rate using continuous compounding formula, that is e raised to r minus 1, where r is 0.08 or 8%, so I got around 8.33, and in your regular equation, that is p into 1 plus I effective raised to n, will give the future sum, and if I substitute this one, I am getting an answer as 216.66 is the future amount you will get. Now all of you can give a try yourself using the formula what I taught you, and solve this problem. A person invests rupees 20,000 in a fixed deposit at a nominal interest rate of 12%. Find the maturity amount he will receive at the end of the year if the interest is compounded semi-annually, quarterly, monthly, daily, and continuously. So what is happening? The total amount he is investing is rupees 20,000. So P is here is given as 20. R nominal interest rate is given as 12. Okay, so this is nothing but your R value. Now we want to find what is the future amount the person has to pay. So the future amount should be combination of the principal amount plus the interest. So what is the interest uh, he will he has to pay? Depends upon the different compounding. So if we are using for semi compounding, sorry, semi annually, quarterly, monthly, or daily basis, all these four cases you have to first calculate the effective interest rate using this formula. Okay, so definitely for semi annually, what will be the m, and m dash is 2. For quarterly, it is becomes 4 quarters, that means 4. Monthly, 12 months, 12. Daily, assuming not a leap year, 365. Now once you find I effective for all the cases using your future some formula, that is P into 1 plus I effective raised to n, you can calculate the future sum in all the four cases. But for continuous interest rate, the formula is different. So here only the changes, only in case of a continuous you have to use this formula. Again the future sum equations remain same, that is F is equal to P into 1 plus I effective raised to n. So you can, all of you can give a try. I'm just in the next slide I'm giving you the answer, and just cross check whether you are getting the answer correctly or not. Okay, so semi-annually m becomes 2, m dash becomes 2, I effective is around 12.36, and maturity amount is 22,470. For quarterly it is 4, amount is 22,510, monthly it is 12, interest effective interest rate becoming is 12.68, and the amount you are getting is 22.536. For daily basis, that is assuming it's not a leap year, we are getting around 365, and the amount is around 22,548. So you can see as the compounding is done, period is go on increasing, you can see the amount is also increasing. So first it was 12,472, it has increased to 12,550 or 12,548 in case of a daily and continuous method. Okay, so in today's class we saw what you mean by effective interest rate, how you calculate them, what you mean by continuous interest rate, and how you calculate them, and we saw using different problems, nature of problems, we understood the interest rate calculations. So if you have any questions, you can contact me directly, or you can even message me. Thank you everyone.